Hello, my name is Colin Greatwood. I'm a mechatronics technology engineer with Festo Corporation, and today I'm here to show you how to set up and control a Festo SMS IO-Link actuator with a Balluff BNI00E1 remote I/O block that communicates IO-Link to the device and Ethernet IP to our Allen-Bradley CompactLogix PLC. A quick overview on the hardware that you're seeing here. You can see on the far left I have a CACN 120 VAC single phase power supply to 24 volts DC power supply from Festo. That 24 volt DC side is powering an Allen-Bradley CompactLogix PLC. Then it's also powering a Balluff BNI00E1 remote I/O block and a Festo SMS IO-Link actuator on the far right hand side. Now you can see the connections at the Balluff BNI00E1 remote I/O block. At the very top, the green connector is an Ethernet connection that's going to my network switch. There's also a white Ethernet RJ45 connector that I'll plug into my PLC's top port. The black connector in the middle of my remote I/O block is for power. That's being powered by the 24 volt DC connectors plus and minus from my power supply. And then you can see that I have my IO-Link connection at the third down on the left. Now this is an 8-port IO-Link master, and there are 4 Class A ports on the top and 4 Class B ports on the bottom. We'll go over the numbering scheme for this a little bit later. Lastly, I have that 3rd port IO-Link connection going to my IO-Link logic port, and I also have the 2nd black cable supplying additional load power to the Festo SMS actuator since this is a Class B device. Next, I'll show you how to parameterize the remote I/O block for IO-Link communication. So I'll open up my web browser of choice and type in the default IP address for the Ethernet IP block, which is 192.168.1.1, and I'll connect. Obviously, in order to connect to that device, I need to make sure that my network connection for my Ethernet port of my laptop is on the same subnet, which you can see here, Ethernet adapter Ethernet. I have my PC's RJ45 adapter set to 192.168.1.100 with the default gateway 192.168.1.1 and subnet mask 255.255.255.0. Since I'm on the same subnet, I can connect to the default IP address. Here's how it looks when you first log in. Now, to have administrator privileges, what you'll do next is click the login button. And for all Ethernet IP remote I/O blocks, the login password is all caps BNI00E1, shown here. And I'll click login. Now you can see that I have a logout icon in the top right, and I have administrator privileges. If I go back to the home page, I'm not showing a device connection here at this 3rd port or the 1st Class B port. And the reason for that is that I have not yet installed the IODD file, so the device is not being detected. If I click on that 3rd port on the Ports tab, you can see it doesn't pull up any parameters because there's no file to assist with connection and parameterization. So in order to upload that file, you'll click the IODD tab. It says no IODD files are present. You can get the latest IODD file by going to festo.com/us/en and typing in the part number or the type code of your SMS actuator. You can find this on the label on the side of the drive component of it. Mine that you can see here is 8102168. I've searched for this before, and I'll go to the device landing page. So this is the SMS rod style mini electric cylinder unit that we are working with today. Going to the download section, software, and then IODD. I'll click the download link here. And that shows up in my downloads folder. After extracting the downloaded archive, I'll go into it and you can see that there's a German version and an English version of the IODD file. We'll come back to that in a moment. In order to upload an IODD file to the Balluff BNI00E1 remote I/O block, you can read some information here on the right-hand side. You can see that this module has a FAT12 file system, which means it has to support an 8.3 naming convention, or my IODD has to adhere to an 8.3 naming convention, which requires the first 2 characters of the file name to be the first 2 alphanumeric letters of the vendor name. So now if I go back to that IODD file and I open it either online or in Notepad, you can search for vendor ID or vendor name, And you can see here that the vendor name is Festo, F-E-S-T-O. So I'm going to use the letters F and E. After that vendor name, first two characters, you'll need the remaining 6 characters of the device ID. So searching for the device ID, you can see it's 607. Now that's a decimal value, and we need to input the hexadecimal value for it, padded with zeros. So for this specific device, the file needs to be renamed from its current name, which you can see here, Festo EPCE TB, and then a date code, IODD11, and we're going to rename that the following, capital FE for Festo, 00025F. If you have any questions about where that 25F came from, you can see here that the decimal 607 we got from the IODD file is converted to hexadecimal 25F. So now that we have our IODD file with an acceptable naming convention, we can upload it to the web server. I'll click Choose File. Now we can upload that properly named 8.3 naming convention IODD file to the web server. I'll click Choose File. I'll find our newly named file, FE00025F, click Open, and Upload. Now it's not detecting devices right away, but we have one more setting that we need to set up in order to work with our PLC, and that's our IP, or static IP address of the Ethernet IP module. I'll go to the Configuration tab, and you can see here that I'm currently at the static IP address for the factory default, .1.1. I'm going to change that to .105, just so I have a unique address that's different from my gateway. And I'm going to click Save Configuration. Now you don't get any pop-up that says Save Configuration has been executed, and it does give you a little note here that says in order to change the IP address, it's necessary to reboot the module. You can click the Reboot button here on the Configuration tab, and that'll start a manual reboot. And you can see that the IP address has changed here in the web server. However, if I open a new tab and I go to that new IP address, which I should be able to, the new tab just keeps spinning, showing that it hasn't taken effect. If I put in the factory default address, .1.1, I can open up another tab. So it seems that the note we had on the configuration tab isn't quite true, and this requires a hard reset. So I'm going to cycle power and then try this again. Okay, now I've cycled power, and I'm going to close my current 2 web server tabs, and I'm going to try the new address again. Now you can see that the web server pulls up on my new IP address that we saw on the home page, and that the old address doesn't do anything. It just spins. Great. You'll also notice that at my third port down on the left, or my first class B port, is that the Festo SMS actuator is now identified. If I log back in using, again, all caps BNI00E1, or sorry, BNI-EIP, and I go back to ports, and then I select the third port down on the left, you can see that the IO-Link master makes use of that newly installed IODD file, and I get a bunch of identification data here on the top left. You can see my process data in hexadecimal, both inputs and outputs, and I get status information from that process data broken out by the IODD file, and all of the available device parameters can be read or written depending on how they're locked down. This web server can be a great tool for troubleshooting, and it's obviously a great tool for dealing with any errors that come up with the Ethernet IP block or the SMS device itself, as well as resetting those errors or figuring things out along the way. But our remote IO block is now complete. I'll stay logged in case we need to come back. So now I'll transition over to Studio 5000. I have my Logix Designer open here, and you can see my components down in the bottom left. First, I'll go and I will open the sample provided for the Balluff AOI specifically, which I've already extracted here. You can see I'm going to be using the Balluff BNI00E1 SMS AOI Advanced. This has the most options, and you can certainly choose to use the basic, intermediate, or IO. I recommend that you get some advice from your Festo representative on which function block or which AOI is best suited for your application. So I'll click the Advanced and Open. Now that we've got our sample PLC project open, I will go over what's included. You can see under your Ethernet network that you have two devices. You have the remote I/O block shown here. It's of type BNI00E1. Obviously, that was installed by going to the device landing page. Obviously, that was installed by going to balluff.com, searching for the specific device, going to the device landing page, and if you scroll down to the bottom, you can see the section Downloads, Software, and you see two things here. The EDS file, which I'll download, and then the latest and greatest AOI or function block. Now, if you're working with the sample provided from Festo, this will have a specific BNI00E1 EDS file already installed, and the AOI will already be installed, but if they're later or newer versions, feel free to replace those along the way. Just to double check, I'll go and take a look at the EDS file, and here's the version we're working with today. It's BNI EIP 538005Z063. If I open that in a quick text editor, here's the version that we're working with, revision 1.1. Mod date is 6/23/2020. So I've already installed that EDS. Now, double-clicking on that device will walk through very briefly the configured settings. You can see that I've set it up for static IP address 192.168.1.105, and that matches what we saw on the web server. I've also set up the module definition for exclusive owner, and this is the default that is auto-populated when you add the device to the network. As for connection, I've set it up for unicast 1 millisecond RPI. You can change this based on your desired installation. And all the rest of the settings are set to defaults. Now that we've gone over the Ethernet device, as well as the configured IP address of my CompactLogix, and you can see I'm running version 33.016 here, I'll minimize the I/O configuration, show you what's under Assets. For add-on instructions, I've installed the SMS Balluff BNI00E1 Advanced AOI. This is from Festo. This is a customized SMS AOI that's built on our standard series. I've also added the Balluff standard AOI that we downloaded earlier. If I go back to my downloads folder, you can see that I also downloaded that AOI. I'll extract it. There are some useful notes here in the revision notes in the notice. It has to do with hardware revision. I encourage you to read those if you're worried that it's compatible with your specific hardware version of the remote I/O block. But here is the L5X file for that AOI. It's already been imported to my add-on instructions. If I click on the add-on instructions and you need to update the AOI, you can right-click on it and click Import Add-on Instruction and reference the file that you downloaded. Once those two AOIs are imported, they'll bring with them a bunch of user-defined data types, and that's fine. We'll leave those as is. We don't modify those at all. I didn't modify those at all. The last thing that we'll need to go over is what's included in your main program. So expanding main program, we'll go first to the main routine, and you can see all I'm doing is calling a subroutine here on rung 0. If you have any questions about how to utilize this sample with multiple SMS actuators on the same remote I/O block, please refer to our interlocked code, as that'll be necessary for this IO-Link master. But we're keeping it simple here. The main routine only has one subroutine call, which is main, so I'll expand on that. So now here we are in our main subroutine. And you can see there's notes along the way. I encourage you to read the comments. So we'll go through step by step, rung by rung. On rung 1, you can see the standard Balluff AOI that's specific to this block, and other Ethernet IP remote I/O blocks might have different AOIs. If you update the Balluff AOI for this block, or you need to use another Balluff remote I/O block, this is the piece that would be replaced. Going into this block, you have a standard tag, and you've got your configuration input and output raw data arrays. This is coming from your controller tags and the 3 data arrays that are set up from your BNI00E1 in the Ethernet network here under I/O configuration. So you'll reference those 3. And this Balluff AOI will produce port-specific data for the 1 to 8 ports. It's an 8-port device. and it's a 1-based index for all of those ports. We're connected here at port 3 currently. We'll come back to that in a moment. There's also an additional little piece of module-specific data for the overall block and its health and system data. And some of that is important for IO-Link. We'll come back to it. So this first rung only just distributes. It breaks up and distributes the raw data coming to and from the Balluff block. Rung 2 is your port selection. Since it's recommended that you only use one SMS device on one remote I/O block without the interlocking code, then you only need to specify a value here under source for the specific port that you're using. You'll notice here in the comments that to enable IO-Link communication at port 1, you should enter value 1, and this goes up in a binary fashion. To enable port 8 communication, you'll enter value 128 here under source. So it'll be 1, 2, 4, 16, 32, 64, 128 for ports 1 to 8 respectively. That's just enabling IO-Link communication or indicating which port you'd like IO-Link communication to be enabled to. Rung 3 will actually activate the port function. All of these ports by default are set up for standard I/O or digital I/O. You can enable the singular port that you're using your SMS on. In this case, it's port 3. When we go online, you'll see this section of code here. Enable my module data port 3 function to be true, or value 16#01. Every other port should default to off. Scrolling down to our next rung, we have rung 4 here. This is setting to, again, our module data, that broken out module data. It's setting a value of 0 to the cycle time, the IO-Link cycle time desired for each of the 8 ports. Now, all this is an override ensuring that the value is set to 0 and that the port will auto-negotiate its fastest speed, whether that's COM 1, 2, or 3, based on the other devices that are connected. You can use this module data to indicate specific network speeds, but I have had trouble with getting this to be consistent, so I do recommend that you leave all of this to value 0 for all 8 ports, whether you have an IO-Link connection or not. Now that we've set up the module itself, we get down into the specific port control. Rung 5 is just the primary control bits for using the AOI on rung 6. We'll come back to those control bits in just a second as we demonstrate function. On rung 6, you can install the AOI of your choice. As I mentioned earlier, we're going to be using the Advanced AOI for this specific Balluff block, and we'll be going over those functions. If you have questions about how to use the simpler blocks, basic, intermediate, or I/O, reach out to your Festo representative. Now going down the AOI itself, just some basic setup things that you'll need to have. Obviously, there's the AOI tag here at the top. You can call this whatever you want, SMS Advanced 1, since we only have one device, and I'm using the Advanced AOI, and I'm giving this controller scope. For the I/O interface, the AB inputs will be the port 3 data .inputs array. So this is a cint48 array. This is what's broken out by the Balluff AOI, and you can see here the port 3 data .outputs array. If I go to the controller tags, you can see here is the port 3 data that's broken out by that Balluff AOI, and here's the inputs and outputs data array. Both of them are just a cint48 array type. Once I've called those specific tag arrays, I'll come down to the bottom. I'll also have a message source element and destination element. These have the same data type, trying to keep things consistent. They're also cint48 data arrays. And then the message read and write instructions here at the bottom. The configuration of this is very important, as Balluff has a unique way of managing the ISDU functions over the message instruction. So for the read message instruction, you'll click a service type custom, service code 32, class 96, instance 3, and attribute 3. The instance here is the one base port that you're connected to. Since I'm connected to port 3, you can see it's the third down on the left, with the top left port being value 1, for instance, and the bottom right port being value 8. Attribute 3 specifically has to do with the reading ISDU. The source element you'll reference here is the source array, the 0th cint in that array, and same for destination for the destination array. The source length is actually managed within the code of our SMS AOI. You don't need to give anything, just leave it at the default. For communication, you'll browse and select the BNI00E1 from your Ethernet network. And the tag's already instantiated as message_read. So then you'll click apply and OK to close, and we'll do the same thing for write with one minor change. The service type is still custom, service code 32, class 96, instance 3 again for port, and attribute 2 for ISDU writing. You have the same source and destination arrays, and again, the source length is managed within the code. Communication is the same path, and the tag, as you can see, is message_write, which is slightly different. So we'll press OK. Everything else we'll see online. So now I'm going to change my camera view and go online with the PLC. So here we are. Now we have downloaded the PLC and we've entered run mode. You can see that I have IO OK, and you can see my SMS in the bottom left corner. Now when the SMS actuator starts up, you may notice that it starts up with an error of sorts, or you're not getting any kind of position in. The first thing you'll have to do is enable the function block. And now I'm using the control bits on rung 5 to make for easy management of the AOI on rung 6. As soon as I enable, you see I get the status enabled bit here on the output side of the AOI. I'm also getting state in and out, which obviously can't be true. State in and out, or a missing state, can indicate that you've started up an error or you need to reference to 0. Since this is an incremental encoder on these things, you have to do a move in or a reference in order for the drive to know where its homing position is. Additionally, you can see here that there is an STS error. So the combination of state in, state out, or STS error will indicate that you have an error from startup, and that may have to do with the power up sequence of your load and logic power lines. So I'm going to clear that error by toggling in quit error. You can see my STS error bit clears, and I have my state device, but I don't have state in, intermediate, or out, indicating one of those 3 positions. That's primarily because since I powered on recently, I need to do some kind of move in or an execute reference so that the incremental encoder that's attached knows where its 0 point is. So I'm going to do a move in, and you can see my actuator in the bottom left corner. It moves in, and I get the state in and state device. So now I'm ready for operation after I've done that first homing run, and I can choose to move all the way out. I can move back in. I can move out again. I can move intermediate. Notice that my intermediate is at approximately 12.5 millimeters. Let's go over a few of the control and monitor tags that are available to you. We've already gone over enable. Move in, move intermediate, and move out, move to those 3 respective positions. In is towards your reference side. Intermediate is towards some middle position that's user configured. If you've recently done a reference, intermediate will be the same as out. So moving out obviously extends all the way. Quitting error clears or attempts to clear a status error, or helps you on the startup to clear that error. Power SMS can be used to, in a non-safe way, manage the load power. So if it's value 1 here, I'll have power on the drive. If I change it to value 0, then you'll actually hear the SMS drive power off, but the logic's still on, so I can't execute motions right now. This is a non-safety way of managing that load power. It's not redundant in any way. It just turns it off here at the tag. Most people end up just defaulting this to on, so when the AOI is on, it is also supplying load power. The user interface lock is a means of if this is value true or 1, then the buttons that you see in blue on the side of the drive will not be usable by maintenance or anybody else. You'll have to set things up via the Festo Automation Suite or the Webserver or via PLC program. So I recommend leaving this to 0 unless you're worried about people messing with your drive. Speed in is a 1 to 10 based value, so 1 being 10%, 100 being indicated by 100% being indicated by a value of 10. That's the same for speed in and force. So if I change this to say value 2 and value 2, and I wait for the right done bit to be done on the right hand side, now I'll do a move out like I did earlier. And you can see it's moving significantly slower in the video. Force is used for after the pressing position, which we'll come back to, is for pressing applications. The reference direction, if it's value 0, then for most of our SMS actuators, that indicates your 0 point in millimeters should be on one side of the actuator. If I was to change this and make it value 1, then that logic would be reversed. And now my reference or homing position would be at full extension. And if I was to use the move out control bit, then I would actually be retracting. So this flips the logic of where your 0 point is, whether it's out or in. Execute reference. This control bit can be used to execute a reference based on the logic of the reference direction. So if I toggle this, and I do have to keep it true during the duration of the test, once it's complete, I can turn it off. And now if I move in, you'll notice your move in is towards the drive, move out is to extend. If I flip the logic that we have there, so I change the reference direction to 1, waiting for the right done, and then I execute another reference, again leaving that reference bit high, and I wait for the device to stop moving. Now if I do a move in, you'll notice that my move in was toward extension. So it is reverse the logic of where my 0 point is or my in direction is. Moving out retracts. I'll flip that one more time just so we're not confused. And I'll verify that in is where it should be in extension or retraction, and out is fully extended. Great. Now return to our defaulted reference position. We'll continue on in our control tags. If I perform a read all at this point in time, right after I've performed an execute reference, and I do have to wait for my read all bit to be complete before resetting, you'll notice that my position start press, end position out, and intermediate position are all set to 30.32 millimeters. It's a scale by a value of 100. So it's recommended, if you're not using the pressing capability of these SMS actuators, that position start press equals the end position out at all times. But I'll set my intermediate position to 20 millimeters, so about a little over halfway. I'll wait for that to complete, and you can see that if I move intermediate, it moves to about 20 millimeters, and out moves to about 30 millimeters, which is reported here at current position. Reading diagnostic data, if this is value true, and you look at the bottom of the screen, right now my current position, speed, and force are the only three things that are updating. Everything else with a DD in front of it, temperature, current, voltage, cycles, total, mileage, total, etc. If I enable this by making it true, you'll see these values start updating. Now this does put additional reading load via the ISDU parameter channel on the IO-Link connection, so it makes things a little bit slower. If you don't need the diagnostic data, turn this off by entering value 0 and only using the top three positions: current position, current speed, and current force. Storing parameters. This should be done if you want parameters to be persistently restored to your drive. Now there is a limit to how many times you can write to this, so if you would rather, you can save those writes and just have all of the parameters you need pushed when you start the PLC program, so just once a day. Auto store active, this is recommended to always be set to 0. So any change that's indicated in the control tags, if this is true, if auto store active is set to true, then any change in the control tags would increment that total number of writes that's been executed at this moment in time. And you can see that current number is 134. So we certainly don't want to run out of writes. So I'm going to recommend that you leave auto store active set to false. Resetting the counter mileage obviously resets the total, the counter mileage that you currently have, not the total mileage, but the mileage since reset will be reset. Enable file handling and execute file handling are used for firmware updates. Please contact your Festo representative if you need to do that. And factory restore, obviously, factory restores your device. Under monitor tags, we've already discussed, you have current position scaled by a factor of 100. So we're currently at 30.32 millimeters. Current speed and force are current feedback from the motor. Temperature, current, voltage, cycles, mileage, cycle since reset, and mileage since reset. And number of storage operation are part of your diagnostic data. If you have any IO-Link issues, that'll be indicated here at latest IO-Link event code, which is different from this next one, AOI error. If there's an issue with the sequence in the SMS Advanced AOI, that'll be indicated here with an integer value. The message tags at the bottom, we've already talked about the configuration there. If you have any questions about how to utilize this AOI or which one's appropriate for your application, please reach out to your Festo representative, as we're glad to help. Thank you very much for your time.